Welcome to lecture series EPG Padasala for Computer Science. In this lecture, we will be discussing software quality assurance models. Major content of this presentation has been prepared from the textbook Software Quality Assurance from Theory to Implementation, authored by Daniel Gellin, Pearson Education Limited, 2004. Learning objectives: outline the need for comprehensive requirements documents and specify the contents of such documents. Explain the structure of McCall's classic factor model. List the factors suggested by alternative software quality assurance models. Identify the stakeholders of quality requirements definition. First, let me outline the need for comprehensive definition of requirements. There is a need for a comprehensive definition of requirements that will cover all attributes of software and aspects of the use of software, including usability aspects, reusability aspects, and maintainability aspects. The great variety of issues related to the various attributes of software and its use and maintenance can be classified into content groups called quality factors. McCall's factor model, product operation factors, correctness, reliability, efficiency, integrity, and usability, product revision factors, maintainability, flexibility, and testability, product transition factors, portability, reusability, and interoperability. The same is illustrated diagrammatically in the form of a tree. Now, we will be discussing each factor one after the other. Product operation factors: correctness, reliability, efficiency, integrity, and usability. Correctness: extent to which a program satisfies its specification and fulfills the user's mission objectives. We are aware that during the analysis phase, the system analyst identifies the requirements and prepares a software requirement specification document, which is a legal contract between the client and the developer. Any issues can be resolved only by referring to the software requirement specification document. The software specification document contains the functional requirements that has to be satisfied by the software. So, correctness is one important factor that has to be considered. That's the reason we have specified the extent to which a program satisfies its specification and fulfills the user's mission objectives. Correctness requirements are defined in a list of software systems required outputs, what we expect the system to do. Correctness example: consider correctness requirements of a club membership information system. The output mission: a defined list of 11 types of reports, 4 types of standard letters to members, and 8 types of queries, which were to be displayed on the monitor on request. The completeness of the output information: the probability of missing data about a member, his attendance at club events, and his payments must be 0. Reliability, extent to which a program can be expected to perform its intended function with required precision. Reliability requirements deal with failures to provide service. They determine the maximum allowed software system failure rate. Reliability can also be conditional. When I mean conditional reliability, I can state the system operates between 9 a.m. and 9 p.m. This is conditional reliability. Reliability example, the failure frequency of a heart monitoring unit that will operate in a hospital's intensive care ward is required to be less than 1 in 20 years. Its heart attack detection function is required to have a failure rate of less than 1 per million cases. Efficiency. Efficiency deals with the hardware resources needed to perform all the functions of the software system. The requirements include the maximum values at which the hardware resources will be applied in a software system. Efficiency example, an outdoor meteorological unit equipped with the 1000 milliampere hour cell should be capable of supplying the power requirements of the unit for at least 30 days. The system performs measurements once per hour, logs the result and transmits the result once a day to the meteorological center by means of wireless communication. Integrity. Integrity requirements deal with software system security. The requirements to prevent access to unauthorized persons, distinguish between the majority of personnel allowed to see the information. Integrity example, the engineering department of a local municipality operates a geographic information system and is planning to allow citizens access to its geographic information system files through the internet. The software requirements include the possibility of viewing and copying, but not inserting changes in the maps of their assets as well as any other asset in the municipality's area. Access will be denied to plans in progress and to those maps defined by the department's head as limited access documents. Let me give you one more example. Consider an automatic teller machine. As a user of the automatic teller machine, you can access the details of your account, you can generate mini statement, you can check the balance, you can perform deposit, you can withdraw money. No other manipulation is permitted in this case. Usability, the effort required to learn, operate, prepare input and interpret output of a program. Deals with the scope of staff resources need to train a new employee and to operate the software system. Usability example, software usability requirements document for a new help desk system. A staff member should be able to handle at least 60 service calls a day. Training a new employee will take no more than 2 days, 16 training hours. Immediately at the end of which the trainee will be able to handle 45 service calls a day. Product revision, software quality factors, maintainability, flexibility and testability. We have already discussed the activities that are carried out during the maintenance phase. During the maintenance phase, undetected bugs, if any, will be detected and corrected. Enhancements to the software, probably changing requirements or re-engineering activities, takes place during the maintenance phase. Effort required to locate and fix an error in an operational program determines the efforts needed by the users to identify the reasons for software failures, to correct the failures, and to verify the success of the corrections. One major problem that comes into picture when a bug is fixed and corrected is fixing the bug and correcting the bug may sometimes lead to ripple effects, which means modification of software in one module may have an adverse effect on another module. Once a change has been done, again testing activities have to be carried out. The testing that is done at this stage is regression testing. Sometimes what happens is, when a bug is fixed and corrected, as I have mentioned, due to ripple effect, a module which was functioning correctly may no more function correctly. That is the reason I said, once you have fixed a bug and corrected, regression testing has to be carried out. So, as I have mentioned, during maintenance, once a bug has been fixed, you have to determine the efforts needed by the users to identify the reasons for failures, to correct the failures, and to verify the success of the corrections. Maintainability example: the size of a software module will not exceed 30 statements. The programming will adhere to the company coding standards and guidelines. Flexibility: effort required to modify an operational program. The capabilities required to support adaptive maintenance activities are covered by flexibility requirements. It includes the resources required to adapt a software package to a variety of customers of the same trade, of various extents of activities, of different ranges of products, etc. As an example, during the maintenance phase, as I have mentioned, you are also anticipated to address changing requirements. We are aware that today database management systems play a major role in any information system. The data accessed and processed by any application program is stored in a database management system. When there is a changing requirement, the designer has to identify whether the requirement change has impact only on the application program, or whether the changing requirement needs a change in the database schema. If the database schema is being altered, the procedures, functions, triggers, packages that run on that schema must also be verified for correctness. If necessary, they must also be modified, and a thorough testing has to be made. If it is only in the application level, it is sufficient that you check your application program which has been modified and verify whether there are any ripple effects due to this change. Flexibility example. Consider a teacher support software which deals with the documentation of students' achievements, calculation of grades, printing of term grade documents, and the printing of warning letters to parents of failing students. The flexibility requirements are: the software should be suitable for teachers of all subjects and all school levels. Non-professionals should be able to create new types of reports according to the school teachers' requirements. Testability. Effort required to test a program to ensure that it performs its intended function. Testability deals with the testing of an information system as well as its operation. Today, when we consider an information system, the core of an information system is the database. Application programs access the data that is stored in the database, process the data, and generates reports. So, testing an information system involves validating whether the structure of the database is created as per the functional requirements, testing the procedures, functions, triggers, and packages that operate on the database, testing the application programs that access the database. Once this level of testing is complete, if the data is accessed through a communication network, test the interconnecting devices like repeaters, switches, bridges, routers, and gateways. Testability requirements software operation include automatic diagnosis performed by the software system prior to starting the system, find out whether all components of the software system are in working order, obtain a report about the detected failures. Testability example: an industrial control unit is programmed to calculate various measures of production status, report the performance level, and operate a warning signal in predefined situations. Once testability demanded was to develop a set of standard test data with known system expected correct reactions in each stage. The standard test data is to be run before production begins to check whether the unit reacts properly. Product transition software quality factors: portability, reusability, and interoperability. Portability: effort required to transfer a program from one hardware configuration or software system environment to another. Makes it possible to continue using the same basic software or hardware in diverse situations. Portability example: a software package designed and programmed to operate in a Windows 2000 environment is required to allow low-cost transfer to Linux and Windows NT environments. Reusability: extent to which a program can be used in other applications. Deals with the use of software modules originally designed for one project in a new software project currently being developed. The reuse of software saves development resources, shortens the development period, and provides higher quality modules. One major issue that has to be addressed when you are reusing existing software is you have to validate the functional requirements, whether the piece of code which you are going to reuse in a new project has the same functional requirements. If there is a change in the functional requirement, identify to what extent the change is. Sometimes when an attempt is made to reuse an existing code, there is a probability that the development time may increase, the number of bugs in the software may also increase. So, a developer must first map the functional requirements in an old project with the functional requirements of the new project in which the code is going to be reused. Perform appropriate reasoning and then reuse the program. Reusability example: a software system is required for the operation and control of a hotel swimming pool that serves hotel guests and members of a pool club. Although the management did not define any reusability requirements, the unit's team leader, after analyzing the information processing requirements of the hotel spa, decided to add the reusability requirement that some of the software modules for the pool should be designed and programmed in a way that it will allow its reuse in the spa's future software system, which is planned to be developed next year. These modules will allow entrance validity checks of membership cards and visit recording, restaurant billing, processing of membership renewal letters. Interoperability effort required to couple one system with another focuses on creating interfaces with other software systems or with other equipment firmware. Interoperability requirements can specify the names of the software or firmware for which interface is required. Interoperability example: the firmware of a medical laboratories equipment is required to process its result according to a standard data structure that can then serve as input for a number of standard laboratory information systems. Alternative models of software quality factors: two-factor models appearing during the late 1980s considered to be alternatives to the McCall's classic factor model, the Evans model and the Willis factor model. Verifiability requirements define design and programming features that enable efficient verification of the design and programming. Most verifiability requirements refer to modularity, to simplicity, and to adherence to documentation and programming guidelines. Expandability refers to future efforts that will be needed to serve larger populations, improve service, or add new applications in order to improve usability. Safety requirements are meant to eliminate conditions hazardous to operators of equipment as a result of errors in process control software. These errors can result in inappropriate reactions to dangerous situations or to the failure to provide alarm signals when dangerous conditions to be detected by the software arise. Manageability refer to the administrative tools that support software modification, during the software development and maintenance periods, such as configuration management, software change procedures. Survivability refers to the continuity of service, defines the minimum time allowed between failures of the system and the maximum time permitted for recovery of service. These requirements may refer separately to total and to partial failures of services. They are especially geared to failures of essential functions or services. Reusability requirements in cases where the client anticipates development in the near future of an additional software system having strong similarities to the present software, the client will himself initiate reusability requirements. However, as I have mentioned, the degree to which both the softwares are similar should be determined. The client is interested in reusing parts of software systems that were developed earlier in a new system. Verifiability requirements. The requirements are meant to improve the design reviews and software tests carried out during software development. Their aim is to save development resources, and they are therefore of interest to developers. The client, however, is usually uninterested in placing requirements that deal with the internal activities of the development team. I acknowledge the authors of the books which I have referred and the web resources I have used for this presentation. Thank you.